All right, let's get started. My goal for today is to finish sections 1.5. Just a reminder, if you're ever confused with what we covered during the days, if you go to our Canvas page under course calendar, there's a button, not the calendar on Canvas. I have the plan for the semester, and if I make changes, I change it. And then you can find the recording of every single lecture there. So that's going to be all available to you. I even put the link to the first quiz there. You can also access it through assignments or quizzes. Some deadlines are coming up, not this week, but next week. Next Friday is going to be our first exam, so the 13th. It's going to be probably mostly multiple choice question. I haven't decided if I'm going to add any short answer in. Probably 30 to 34 multiple choice questions. It's going to be in the second half of our class. So yeah, that's gonna be coming up, but before we hit Friday the 13th, oh, I forgot, it is Friday the 13th, no worries. Everything is going to be due so far. So you have, right now you have 3 homeworks open. It is now added to the Canvas site. So you can access it through our Canvas site. And I will say, be patient with the population, because let's say you have a 100 in Macmillan's site, but you have maybe a 20 in the Canvas site. Sometimes it just takes your next login to have that populate. So it might take a little bit of time for it to come in. But if your Macmillan site says you have this grade, that's going to eventually be in the Canvas site. And then of course you can always email me and I can check and confirm. But those homeworks, I believe I'll probably make another homework for 1.6, 1.6. They're all due at the beginning of that class time. So the more you do now, the less you have to do later. That's my motto in life, is the more I do it for future me. Like future me would love it if I got all of this hard stuff done now. So those homeworks are going to be due, and then we have a quiz every single week. So I will not have a quiz next week because we're going to have the exam, but you'll have already opened quiz 1, which covered last week. And I'm almost done. I think on Friday I will release quiz 2 because it's going to cover what we've covered that week. And I don't know how many questions will be on it. It just depends. I think the first quiz had like 5 or 6 questions, but it's everything that we covered. And then you can study for them by looking at our slides and activities. I mean, that's the best way to study them. Okay. Those are also due at the beginning of our. Any questions?
The quiz is done in person or just?
They're on Canvas.
Oh.
Yes, I have it on Canvas just because I want to make it easier on y'all. You get 2 attempts. I keep your highest attempt. So if you don't like your grade on the first attempt, you can see your answers and see what went wrong. Go ahead, restudy, do what you have to do, and then attempt, aim for a little bit higher. And then there are going to be some open essay questions that rely on me grading. So those you don't quite know about, but everything else you'll be able to improve. I do have 2 drops written into the syllabus where I will drop your 2 lowest quizzes and your 2 lowest homeworks. Please don't let that be the first ones. I know some students are like, well, I'll just use the drops now. Those are the students that later on have a legitimate emergency and they're like, well, what do I do? I'm like, well, you used it for your drops. I can't help you. Please, what I do now if I'm ever taking a course is I'd rather drop it towards the end where I'm really stressed out with other classes and finals. I'd rather drop those than drop the ones. Get the easier ones out. I wouldn't even drop a quiz. Quizzes are a great way to study. So like do the quiz and your lowest 2 will get dropped, but don't not do the quiz and not study. Any questions on those deadlines? Okay. All right, so you can see where you stand in our Canvas gradebook. So you can see the homework grades, you can see the quiz grades. I haven't finished grading the quiz. It'll be a little lower because I haven't hand graded those specific questions, but I'll grade them probably within 48 hours. Okay, let us continue on with significant figures. You will need a calculator for today, maybe initially, but later on you'll need a calculator. So if you have one, get one out for us to use later. Let's talk about significant figures. They are very important in, I guess, lab sciences, especially in chemistry. And we're going to definitely go over the rules of significant figures. It might seem very overwhelming, but you'll start seeing patterns and you'll get more and more comfortable with them as you see them. So let's go over the basic rules. Non-zero numbers are always significant. So let's say I wrote 42. Since neither of those are a zero, then that would be, both of them would be significant, and that would be two significant figures. So I might ask you how many significant figures and things like that. If I was to throw in a zero in there, like if I was to do like 10, then the one would be significant, the zero would not. But zeros are a little finicky, and there are certain rules around zeros. So zeros at the beginning of a number are never significant. So typically we would do zeros when we're dealing with decimal places. So if I was to do 0.01, the one is absolutely significant, but any zero before the first non-zero number is insignificant. So these numbers are not significant figures. But if I added zeros after, they would be. That would be the next one. But just be comfortable knowing if I was to add like a bunch of zeros, all of these zeros leading up to the first non-zero digit are not significant. So in this question, how many significant digits are in this number? 3. So none of the zeros before, the 3 after, so 5, 2, and 9 are the significant numbers. So zeros in between non-zero numbers are always significant. So if I was to have 1001, it's neither in front or behind, so those would absolutely be significant. So how many sig figs are in 1001? 4. Don't get tripped up. Don't think it's 2, because those 2 zeros in the middle absolutely matter. And then zeros at the end of a number are significant when there's a decimal point. So this was when it kind of does get confusing. If I was to say 100 and 100 point, how many sig figs would be here? So that's where it gets tricky, because I don't have a decimal place. So this one would absolutely have 3 sig figs, because that decimal place tells you it's significant. But this one does not have a decimal place. So this one only has 1 significant figure. That's when it gets tricky, when you start getting the numbers in front. The numbers for after the decimal places are a little bit more simple. But if I was to, like, let's say do 23,900, how many significant figures are in that number? Yes, 3. If I was to maybe add a decimal place to the end of it, how many significant figures? 5. This might seem very confusing at first if you haven't seen them a lot or you're a little rusty, but my biggest piece of advice is to practice, which we were going to do a lot of practicing today. I still recommend blurting out the answer, even if you might be wrong. There is nothing wrong with being wrong. I just love to hear y'all think. So we'll do a lot of practice for an upcoming slides, and our activity for the day will be doing significant figure practice. So lots and lots and lots of practice. That's the only way we can get better at this. All right, so let's go over these. In the lab, we are going to start having units because we're doing measurements. So don't worry about those units at the end. I'm just focusing on the numbers themselves, but the units are always relevant. So let's look at, number 1. How many significant figures?
2.
2, yes. If I was to have a decimal at the end, that would change it, but they don't. So this one would have 2 significant figures. What about number 2? Yes, 3. This 0 is not significant because it's before the first non-zero number. So that one would not count, and this one would have 3 significant figures. Number 3? 3, I agree. So the 0 in the middle of 2 non-significant numbers are always going to be significant. All right, what about number 4?
Oh.
Yes, so we're starting to get into like this limbo land. This 0 at the very end, that is significant because it's after a decimal place. So previously, if it was like 100, it wouldn't count, but once you include those decimal places, any 0 does count. So that because this one's after a decimal place, this one would be significant. So in this case, this one would have 4 significant figures. All right. What about number 5? So it's starting to get a little bit tricky, right? So these zeros do not count because they're of course non-zero numbers, but these 4 do count because they're after the first non-zero and a decimal was involved. So this one would be 4. What about number 6? Probably the easiest because everything is a non-zero. Zeros are just weird. What about number 7?
Cool.
Yes, it's 4. Why? Because of that decimal place. That is, you can see how like there's so many ways we can go wrong with this. And that's why just seeing it over and over again makes it a little bit better. Because of that decimal place there, these 2 zeros absolutely are significant. So this one is 4. What about number 8? Yes, 2. So these zeros do not count because there is no decimal place. So we need 2. There's a lot of ways that we can throw in these zeros. We're not purposely trying to trick you, but there are those special rules that we want you to get more comfortable with, even if, I mean, I'm not asking for memorization, but I will say the more practice, it just comes naturally. So no worries if this is confusing, the more we do it, the better. I don't know when elementary or middle or high school we learned it, but we learned rounding at some point. If I was to have the number 5, how do I know how to round it? Do I round it down? So 5 would go up. All right. So for me, when I learned rounding, 5 was like literally halfway between 1 and 10. And so I'm not always where you round it. So for me, it would have to be the next digit after the 5. Does that make sense? Like, let's say if I had 10.58 and I want to round this to 3 significant figures. How would I round 10.58? So that 8 is closer to the top than the bottom, and so that one would round up to 10.6. If the number after it was something smaller, like a 2, what would it round to? So it'd stay to 10.5 because that 2 would round down. So I'm sorry, I would kind of went in the wrong direction at the beginning of that, but hope a little bit less confusing. So it's in here, look at the next decimal place to see where you round up or down. So if we're trying to get 3 significant figures, are these zeros significant?
No.
No. So I'm not even going to focus on them. I'm going to count 1, 2, 3. And so that's going to be where I want to stop. So luckily it's a 1, so I can round down. Because I don't have to round really anywhere here. It's everything's low. So 0.00581. Okay. Where is the 3rd significant figure for the next one?
The 1 or the just, I guess
The 1 or the 3? So what?
the second.
Yeah. We're trying to get it to 3 sig figs. This is where it kind of gets confusing. If I wanted to do 3 sig figs, I can't just do 133 because that's not the number that they gave to us. What do I have to do?
Change the 1.
Yes. So I can't have 1331 because that would be 4 significant figures and I'm asking for 3. And that's when it can get a little bit confusing because this doesn't make sense. It's 1,331. But in this case, I really want you to be to 3 sig figs. So the only way to get rid of that 1 is to round it either up or down. 1 is closer to 0, so I'm going to round down to 0. So, and then I'm not going to add a decimal place to it because that would make it 4 significant figures, and then I would have just left the 1 in there. So yes, that one was a little tough. How do you feel about it now? We have some more options to like do something similar. Go ahead.
So in that case, if the 1 that said it was a 6.
Yeah.
the 3 would change to a 4.
This 3 would change to a 4. Excellent question. So you'd still have to like do some rounding there and leave with a zero, but that would definitely affect how you would write this number. So, because it's a one, yes, if it was asking before, that one would definitely be significant. What about the next one? How about? Yeah, someone just, do I put a zero up front? Like, can y'all just read it to me? What do y'all think?
10015.
Yes. So these zeros don't count as significant, so the very last decimal place needs to be right here. And because the next one is a 5, 5, or even just a 5, I think it would just round up. So 0.00154. And then I want you to also get in the habit, I haven't been doing this, but if your answer has units, always add those units. I know if it was a multiple choice exam, you don't have to worry about that, but if you were ever doing short answer or while you're doing these worksheets, just get comfortable if there are units, add those units. This is when students kind of skip those steps and we see like mistakes later on, and they would have done a great job. I think they just missed a couple of things, so just make it a habit. Number 4, all right, so since it's no zeros, this one's pretty straightforward on where the last decimal place will be. It'll be that 2. So I need to write 1, 6, and then after 2 is a 9. So what should it be? 3. But I can't have any more significant digits, but 163 is not correct. What do I do? Yes. So this number is not 160. So if I just put 163, that would be way, way, way off. But in order to have it at least be correct and the amount, add those zeros that are non-significant so I can still have, the correct amount. Number 5. So it's gonna be 0 point, and then that last decimal place here. So 1, 2, 7. And then do I need to round the 7? No. So the next number is a 0 and a 7, so. All right, I'll give y'all a minute to do the next 3 on your own, and then we'll review the answers. All right, what did y'all get for number 6? This is the one where I'm like, okay, well, it's a 5, 0, so it could go up or down. So I think for me, I would probably round this one up, but I think you wouldn't get the answer wrong if you had it at 188. The reason why I say that is this is a multiple choice exam. You would just have 188 or 189. It would be one or the other. If this was a short answer exam, you would have done it right anyway, as long as you had it to the correct sig figs. So in this case, I'm going to say 189 because the rounding, yeah, 0.5 would probably go up, but it's a 0 next. Sorry, I'm getting into like higher up sig figs, and I'm trying really hard not to confuse you, so I would accept both. Number 7, this one is note that all of these zeros are not significant, but I have to include them. All right, and then Sarah.
6.
Why don't I just have it as 1, 6? I need 3 significant numbers, and right now with 1, 6, it would be just 2. So 1, 6, 0 would make it 3. What about number 8? I agree. Okay. Y'all got really good at that really fast. So good, 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 good. Are there any questions on these numbers or rounding?
Why would 188 be acceptable for 6? Keep going further down the line, you can see that it's over 5.
Yes, so for me, when I do upper, this is like higher level rounding. For y'all, it would be 189. I think it would always be 189. But for me, it's always number after the 5, and since the number after 5 is a 0, that makes it go down. But that's higher level rounding. Like that's me getting into 3,000 level chemistry. So if you're there, then I just don't want to take some, if I would say it's correct when I teach a 3,000 chemistry, I'm not going to take off points for y'all now. But for, I guess, Gen Chem level, it would be 189. So sorry, I don't want to confuse you more when I think both are correct.
Like the numbers after the decimal was just not. Right?
Number
And right
4,
at the end.
number 4.
Yeah.
So you can't round them. So it might or might not be significant, but if, let's say, only 3 decimal places or 3 digits are significant, they would not be significant. It's like, it's what the question is asking. So because it only wants 3, anything that's not 3 doesn't matter. This is also, a great example of, let's say I ask you a question on an exam. And in your calculator, you get 20,000 decimal places. You don't want to write 20,000 decimal places. So sometimes being able to write it to the correct significant figures can save you a lot of time and effort. We're going to get to that. So there are such thing as exact numbers and uncertain numbers. Last class, we definitely talked about uncertainty and how when we're doing measurements, there's always going to be a level of uncertainty if you are reliant on, let's say, a tick mark or between tick marks where it's not so certain. So sig figs only apply to the uncertainty associated with experimentally measured numbers. So I mentioned that if your scale has 4 decimal places, all of them are significant. Even if the last decimal place is a little uncertain, it's still significant. For you to measure with, I don't know, a ruler, if you wanted to measure meters, whatever we got on it, it would be significant, even if it was a little bit uncertain, that last decimal place. But that's only when we're measuring in a lab or with measuring tools. There are exact numbers where it is exactly this and there is no uncertainty, and those will be significant. So examples would be like if I was to do a conversion. So 100 centimeters equals 1 meters. There is no uncertainty there. 100 centimeters equals 1 meter exactly every time. This is a water molecule. There's exactly 2 hydrogen. I am not uncertain at all about how many hydrogen are present. I'm not uncertain at all about how many oxygen. There's 2 hydrogen and 1 oxygen. For most constants, I would say in Gen Chem constants, but when you get higher and higher up, it gets more. But most constants, they are exact numbers. So the speed of light is 3,000, sorry, not 3,000, 3 times 10 to the 8th meters per second, exactly. And then precision lab equipment such as volumetric flasks. So volumetric flasks, when you hit Gen Chem 1, they look like this, and they have only 1 line because they can only measure 1 volume. So if you hit that line perfectly, we know it's exactly that number. So if it's a 100 milliliter volumetric flask, then it is exactly 100 milliliters that are in there. So that's going to be exact numbers. If you had something with a bunch of ticks, like that graduated cylinder we showed last class, I am not an artist. Let's say it had a bunch of ticks like this, then that one would have an uncertainty in there. So it'd still be significant, but that one would have a little bit of uncertainty. We're going to move into writing in scientific notation. The biggest thing I want to talk to you about is these are not significant figures. They will never be included into significant figures. And I feel like students will always accidentally get tricked into thinking they are. So they are used to kind of tell you where things are away from the decimal place, but they're not going to be a part of the significance. Right. We use scientific notation to help us write easier because sometimes numbers are incredibly small. Sometimes numbers are incredibly big, like zeros. So it's a way for me to kind of be more efficient as a chemist. But it could go either way of the decimal place. And the best way to do this is to kind of like identify the decimal place. And if it's a negative number, you're going to the right of the decimal place. What I mean by negative is this will be negative, this exponent. So if it's going to the right of the decimal place, it's a negative exponent. If it's going to the left of the decimal place, it's a positive exponent. So if I move the decimal place 1, 2, 3, 4, then that is why I now have 1.35 times 10 to the negative 4. Also, I have 3 significant figures here, and I have 3 significant figures here. If you do have to turn anything into scientific notation, keep the sig figs. But remember, ignore this. This is not sig figs. For the next one, since I have a very, very large number and I don't feel like writing out all those zeros, I can assume there is a decimal place right here. One, 2, 3, 4, 5, 6, 7. And that's where I can get 1.89 times 10 to the 7th, because it's a big number. There's only 3 sig figs here. There's going to be only 3 sig figs here. It is possible for me to like write it like this. If I was to like do 18.9 times 10 to the 6, those are the same answer, but we tend to make it as simple as possible. So we want the decimal place after the first number. And you use a calculator, your calculator will also always spit it out with a number like this. So number, decimal place, whatever, times 10 to the. Any questions on that?
Don't always want to get, like single digit, front of the decimal point.
So I would say that's going to be the general rule to do it like that. There are going to be some cases when you move into like, I don't know, a long time. I don't know if you get there, but like quant and upper ones where maybe I start asking math that requires you not to. But in this case, you want to be very comfortable just doing it one or number dot something. Why does a multiplier have a -4 rather than a 4? That is an excellent question. The reason why is because we're moving the decimal places in different directions. So when you have a very, very small number, I have to move the decimal place to the left. And if I move the decimal place to the left, the 10 will have a negative number. If I move the decimal place to the right, or wait, I got that backwards. All right, so if I move the decimal place to make a tiny number appear bigger, that's why it's going to have a 10 to the minus sign, because I am moving it to the right. If I move it to the left, because I'm making a bigger number appear smaller, it's going to have a positive exponent. I highlighted on this last page to just notice the trend that when you do scientific notation, try to be consistent with those significant figures. So if I have my answer or all those zeros have 3, you want to have your scientific notation mimic it. I keep saying it over and over and over, not significant figures. Any questions so far? Let's practice converting. So I'll do one and then I'll give you some time to work on it on your own. But remember, it depends on where we're shifting that decimal place. So this number is quite small. So I'm going to have a 10 to the minus number. First, how many sig figs? 2. So I want my answer to have 2. So I'll do 6.7 because I know it has to be 2. And I'm going to move the decimal place 1, 2, 3. So it'll be 10 to the minus 3. All right, and I'll give you a few minutes to do the rest. Does anyone need more time? Okay, for number 2, how many sig figs? Or 5. The 0 is significant. So my answer would be 9.8530 because I have to make sure I have the same amount of sig fig. Wait, 1, 2, 3, yep, I have 5. Will the 10 to be to the minus or the plus? Because the number is very small and I'll be moving the decimal place to the right. How many times? 5, yes. So as you do this, you'll start being more and more comfortable with this, but that's how I kind of do it, is start by figuring out the sig figs and then just moving the decimal place. Number 3, how many sig figs? 2, so I'm gonna have 2.3 times 10. Now I'm gonna go in the opposite direction, so 1, 2, 3. So it'll be 10 to the 3. Oh, 4. Yeah, thanks for catching that. 1, 2, 3, 4. That comma got me. For number 4, how many sig figs?
3.
3. 1, 2, 3, 4, 5, 6. Did y'all get that? Awesome. Now we're gonna go from scientific notation to regular. So this is a positive number, so this number will be bigger. So it'll be 602, 1, 2, 3, 4. So I have to add 2 extra zeros. So I still have 3 sig figs, but now it's all written out. Now it's gonna be to the minus 4. So 1, 2, 3, 4. So I'll have 3 zeros out front. 1, 2, 3, 6, 0, 2. Still has 3 sig figs. And yeah, 10 to the minus 4. How do you feel about that? Awesome. It depends on if it was a multiple choice exam, because your answer would be in front of you either, and if it's one way or the other, you'll have that option. It's also important for you to be very, very comfortable going back and forth. If this was a short answer problem, if you wrote in either or, you would be right either way, unless I was to explicitly say write in scientific notation. You wouldn't get penalized, if you were right either way. All right, let's practice doing multiplication and division with no calculator. I know it seems overwhelming, but we can absolutely do it with our base algebra rules. So if I had the numbers with exponents, how could I simplify multiplying exponents? You might be rusty, no worries.
Well, if the numbers, like the finish numbers were the same, you can just get rid of those.
Yeah, so like, I don't know, if you had algebra in high school, I assume we all did, at some point, we kind of talked about x to different exponents. So for us to do this, it would just be x1 plus 2 or x to the 3. We're using those exact same concepts here because these numbers are going to be the same. 10 to the 7th is the same thing as me saying x to the 7th times x to the 41. So what we're going to do here is we're going to practice doing this without any math. So the way that we want to do this is the exponents are 7 and 41. We add them together, and that's going to be our new number. So what is 7 plus 41? 48. So the number out front doesn't change because it's the same thing. Just assume it's like an x. It'll be 10 to the 48. So the numbers out front might be different, but we're still going to use the same concept of take those exponents, add them together for multiplication, subtract them for division. Okay. So here, 10 to the 23rd minus 10 to the 6th, that would be the same thing as me saying 10 to the 23rd minus 6. So 10 to the what?
17.
17. Yes, absolutely. We're doing exponent math without any calculators. I'll tell you now, I still don't trust myself sometimes, and so I'm still on my calculator double checking, but it's really exciting to know that I was able to do this without my calculator. What about number 2? So I have a negative. So if I take 20, or if I take -5 plus 25, what do I get? 20. So my answer would be 10 to the 20th. And then number 2 on the other side, I have 10 to the 23rd. So I'll do 10 to the 23rd minus -6. Going back way back to, I forget when we learned this. I don't know. Elementary math? I don't know. Maybe middle school? It's been a long time. So what's 23 minus -6?
29.
Yes, because you have a double negative here, it'll end up being a positive. And so that would be 10 to the 29. Okay. I'll let you do the next 4, and then we will check our answers. Does anyone need more time? Okay. So number 3, we have 23 and 6. What did you get?
17.
Yes, so 10 to the 23 plus 6. Okay, and then number 3 over here?
That's why it's here.
Yes, 10 to the 2 or 10 squared. Okay, number 4.
Then we go.
So in this case, it would be 23 plus -3, whereas on the other side, it would be a minus negative, and that's why it turns into a plus. But 23 plus -3 would bring it down to a 10 to the 20. No worries. I also kind of got that one wrong. I had to double check it. All right. So on the right, we have 10 to the 5th minus -6. What do you get? 10 to the 11th. Because this is a double negative, it turns into a positive. Now we have 10 to the 11th. So just so you know, because I would say this is a lot harder than what you might really see. But being able to kind of do this in our head helps us fix answers we might make a mistake with our calculator. Sometimes if you accidentally type things wrong onto your calculator, we think, okay, our calculator can't be wrong. So we just blindly write it down as our answer. But our goal in this course is have you kind of critically think and say, well, I got this answer, does it make sense? And so this kind of helps at least me. If I know my answer should be like in the ballpark of 10 to the 5th, but when I type in my calculator, I get 10 to the 47th, there's no way. And so I can go back and say, okay, where did I make a mistake typing it into my calculator? So that's why we're doing this, is because you are capable of like figuring this out. And hopefully by us doing that, we can kind of catch our mistakes later on. I do that all the time. All right, let's do one step further. Can we do this math without a calculator? So first, kind of break it up into 2 steps. If you are one of those who like can do it in 1 step, good for you. I'm jealous. Teach me, but I can't. So I break it into 2 steps. So I start by looking at the beginning. What is 6 times 3? 18. Now let's do what we did in the last one. So this is a multiplication. So I have 10 to the 23rd times 10 to the 3rd. What is my exponent going to be? 26. Okay. So here's one of those cases where like, if I was to leave it, this is absolutely correct. We were trying to get you to do this, but if you wanted to kind of write it, we'll have to do it 2 ways. If you want to be consistent like before, I could move the decimal place here, and that would make it 1.8 times 10 to the left, I guess 27. Yeah. So that's one way you can write it, but both of these are correct. Now, what am I not? How many sig figs? So in 6 times 10 to the 23rd, how many sig figs? And in 3 times 10 to the 3rd, how many sig figs? Yes. So sometimes you might have to write your answer based off the math. In this case, I'm going to leave it as 1.8, but we're going to do some slides later on. I want you to really think about sig figs, because if I had only 1 sig fig for both of these, I'm not going to have my answer have like 50 sig figs. So try to keep it short and simple. All right, move this.
Don't multiply everything in the like brackets, or is it because it's not it's an important.
You mean like, why didn't I type this into my calculator like this?
Like, when you multiply like
Are you-
brackets, you gotta like,
Oh, you're trying to foil it?
yeah.
So you don't foil it because these are one number. So this is essentially me taking 6 times 18. It looks like, you know, like 6 plus 3 times 4 plus something like that when you foil it. This is just one number. So number times number. So that's why 6 times the notation is absolutely consistent. So I want you to get comfortable recognizing that it's 10 to the minus something, that's just a part of the one number. Okay. Now this one, I'm just going to switch it up and not do 0.02. I'm just going to leave it at 6. All right, and I'll show you why it doesn't matter. What is 6 divided by 3? Okay, so 2. And then what is 10 to the 23rd divided by 10 to the 3rd? 10 to the 20. Okay. If I was to type this in my calculator, I would end up getting like 2.00000002 times 10 to the 20. So that's why it really doesn't matter. It's 6 is pretty much 6, or 6.02 is pretty much 6. And so I know my answer should be around 2 point something times 10 to the 20. So even if I have these decimal places, I'm still able to critically think and say, what should my answer be around? And then if I have to be exact, then I will. but I love this because I'm like, okay, well, I don't need my calculator, which in reality, I will always rely on my calculator. It's good to know. I always try to do things in my head and then I check my answer later on. So I'll give you a few minutes to do these. Please, please, please try doing it in your head. And if you really want to check on your calculator, go for it. But head first. Does anyone need more time? No worries if you do. Gotta make sure everyone has a chance. For number one, what did you get?
And for the same.
Yes. You can also write it as, I think, 3.5 times 10 to the 16th, right?
10 to 8.
10 to 18th, okay. They're both right. In this case, we want to be consistent, 35 times 10 to the 17th. Okay, what about number two?
13 times 10 to 20.
So 8 divided by 4.
Oh,
No worries, no worries. See how it's like, okay, we kind of know what it should and shouldn't look like. That really helps us figure out our mistakes. What is 8 divided by 4? 2. And what is 10 to the 25 divided by 10 to the 5? Yes. Y'all are on it. So this is great. Even if we make mistakes, we can easily figure it out. All right. Any questions about that? And then, like I said, when you're doing an exam, honestly, try to think about what your answer should be, but always double check. If you have time left to do it, double check your answers just to confirm. Because if, let's say you and the calculator disagree, maybe you check things in the wrong here, or maybe you didn't do the math right in your head. So that's what I would do. If I got a different answer, I would then type it, see what happens. Let's practice type into our calculator. So there are several ways for us to do this. Let me switch to my doc. Okay, let me just go over this and then I'll switch to the document. So 6.02 times 10 to the 23rd is entered a certain way. So I want you to open your calculators and find the EE button. So does everyone know where that's at? If you type out times 10 to the whatever with the carets, you'll be right, but that's a lot of effort when you can save yourself time. So if you use this capital EE button, that's me typing times 10 to the whatever. So the number you put after it represents what's in the exponent. Also, this is important because sometimes students, if I was to say type in 10 to the minus 6 in your calculator, you can do 10 to the caret minus 6. That's one option. Or you can type in 1e minus 6. Don't type in 10 times 10 to the minus 6. That would no longer be wrong, right? That would be like 10 to the minus 5. So either or, just be comfortable doing it. Let's switch to my DocCam. That's not it. Okay. So all of these calculators should have a capital E button. So mine's right here. If you have a calculator like mine, reminder, you are not allowed to have a graphing calculator for an exam. So I will have extras of these. I will always have extras. No student's going to be allowed to take the exam without a calculator. But when you're practicing or doing your homework, try practicing with a calculator that you're going to use for the exam. Because I would hate to give you a calculator that you can't use second. We'll do our little break after this. I would hate to have a calculator you can't use or unable to use or confused by on exam when it's really, really important. So if I want to do 6.02, I'm going to go to this EE button, and then whatever number after that is that going to be my exponent. So set 6.02 times 10 to the 23rd. It's the same thing. If I was to type that in, let's do times, oops, sorry. Do you see how much time that took me to type it in? Yes, I would be fine. I would be fine either way, but there's more chances for me to make mistakes. I'm wasting time, and I want to get very comfortable with that E button because you're going to be using it a lot. Okay. Same thing if I wanted to type 10 to the 6th or the -6 power, I can do like that. So where I use my little exponent button, or you can just do 1e to the 6 or -6. So I want to make sure that you're very comfortable going back and forth, because when you hit Gen Chem, or even towards the later parts of this course, we're going to be using this a lot, and I want to help us get more comfortable with these calculators.
It's like the 0 to the -23.
Yeah. So great question. And then I want to use the E button. There's a little negative sign right here. Your calculator might have like a negative somewhere else. I think the Texas Instruments tends to have in the bottom right. So -23.
So it's like 10 that use more.
Yes. Yeah. And I'll be honest, I prefer to just do 10 to the like that. That's just that works better for me. You have to do what's best for you as long as it works. Sometimes students will try to like come up with their own methods, but it's not consistent with the right answer. That's my only worry. So I am never going to tell y'all to be in my box, do what I do, but this is kind of just works for me. So if I was to type things in my calculator, you could do, let's do the math from the previous one. So 8, I think it was 25 divided by 4 e to the 5. I think that's what it was. And we got the right answer. You don't need the parentheses because it is all one number. So I'll type it again. I am just a stickler for parentheses. So let's try that again. 825 divided by 4. You'll get the right answer. If you start incorporating more numbers, then you really want to start thinking about parentheses. But because it is one number, it's okay to not have it if you're just doing those two numbers. Okay. Why don't you practice doing that math real quick in your calculator? See if you can type that in. Let's see if I can zoom. That's the brightness. I also want to point out, do you see right here? This, I know it's blurry, but my calculator says DEG for degrees. If your calculator says radians, or if I go to mode real quick, you see degrees, radians, or grad. I don't know what grad stands for, but you want your calculator to be in degrees. So if you are getting the wrong number when you type things in, that might be what's happening. So you just go to the mode button and then switch it to degrees. So I'm gonna enter, maybe there. Okay, so yeah, it's in degrees. Okay, is everyone good on that? All right, so right now it is 12:53. Let's take a mental break and we'll come back at 12:54. We'll come back at 12:59. So I'm gonna pause the recording and I'll start it up again for the next half. Okay. Sorry, some things with Zoom. There we go. Okay, let's continue. We're going to be working with our calculators and answering some problems. So our goal is to use calculators quickly, thoughtfully, and most important, accurately. So if we can save a little bit of time and ensure that your answers are the best they possibly can be, that'd be wonderful. sometimes we learn habits. I feel like when I was going through this, I'm like, oh, I even have bad habits I need to break myself. So our goal is to unlearn some bad habits that will give us the wrong answers in the end. That might have been successful previously, but just my habits are just because I take a lot of time to put things into my calculator. And so Dr. Patterson's methods might help us be a little bit more efficient. So the 3 bad habits are entering a number in scientific notation any way other than the E key. Not because it's wrong, but because it's not efficient. So our goal is to use the E key to make our lives a little bit better by going quicker. So this EE key is just a way for us to save time and be better. It's also because like sometimes when you're doing it typed all the way out, it's like you have to, it could be a little messy if you don't put parentheses and stuff like that. Using parentheses to mean multiplication instead of order of operations. Now, sometimes I don't completely agree with this, but if you don't know how to use parentheses correctly, it will definitely hurt you. So I use parentheses, but I use it for very, very high levels of big equations. But it's important to know how to use them. So using that multiplication sign also helps. Doing part of the calculation, writing down the intermediate result, and then typing it back in at a later step. This would give you the right answer in the end, but it also cuts or takes a lot of time to do. So our goal is to help you become a little bit more efficient while being accurate. So we're going to work through this practicing and not having to break things up into a million steps. Let's practice in our calculators right now. So get out your calculators and type in this and see what you get. I do skip steps in my calculator because 32 and 32.0 are correct. So in your calculator, you don't have to spend time putting in that 0.0, but if you were to answer, always have it in significant figures, but you can skip adding that in. You should have your calculator look like this when you type it in. Okay. What did y'all get?
5.315.
Okay, what's the next one after 5?
5, 6, 1, 4, 6, 2.
Okay, and then times 10 to the what?
Negative.
I believe this is 10 to the 1, right? So if I was, huh? To the 0? Yeah, makes sense. Yeah, that's why it would be negative 23. Perfect. Just going off of what we just did, but if you type into your calculator, you would get something like this. Now, here's a tip. How many sig figs are here? How many sig figs are here? So typically you want to kind of pick one that's around the ballpark. If there were different amounts, you'd pick the one that has the least amount of sig figs. So in this case, they both have 3, so my life's a little bit better. So I'm going to go here and it's going to be 5.3 what? 2. 5.32 times 10 to the minus 23. That's going to be the answer. If anyone did not get this answer, please let me know because I want to make sure that we're typing this in right. All right, so big idea is round your answer to the same number of sig figs as the starting measurement with the fewest sig figs. So whatever you're typing into the calculator, whatever has the least amount of sig figs, that's going to be probably around, sorry, I just got a text message. Yeah, so if you have 2 sig figs and then 3 sig figs that you're typing in your calculator, your answer should be 2 because it's the least amount of sig figs. So count the number of sig figs in every number being multiplied and divided. Round your answer to the smallest number of sig figs you counted in number 1. Let's keep practicing. Oh, sorry. More tips and tricks. Start with the number on top. Hit the X or multiplication key before all other numbers on the top. No parentheses. What she means by that is if I was to have a bunch of numbers, let's say 8, times 3 times 4 times 2 divided by, let's say 5 times 3. You don't want to do this, 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 because that would be like a waste of time. You're welcome to do. Sorry, one more. This, parentheses before and after the end of it, but you definitely want to be including those multiplications. And then I'll put parentheses here. That would be correct. Hit the divide key before all other numbers on the bottom. So yeah, I like to break it up in the top and the bottom, and then optional, wait, sorry. Hit the enter key after the last number, and then optional hit the enter key after every number. Depends on what you think is best. Okay. Let's practice. So I do want to point out that in this problem, this, and this are not, they would not be written into the problem itself in a way. And I wouldn't use those as your sig figs. I wouldn't. I would use probably either this, or this as your sig figs. But since they didn't give me the problem itself, I can't really make a deterrent. So I would definitely have your answer not be beyond 4 sig figs. So, not trying to confuse you. On the next one, we'll be able to answer this one. This one's just giving you an example. So right now, I want you to practice typing this into your calculator. There are 2 ways you can do it. First way is you can take all of those top numbers and multiply them together. If there's a 1, it's not necessary to include if you do it like this. So type all those top numbers together in parentheses and then divide by all of the bottom numbers. Remember, you don't have to do a 1. So that would look something like this. 25 times 1 times 6 times 18.02, close parentheses, divide 1. Once again, I'm adding the ones in because I have to, but if you were typing this in, you don't need to include them. And then what do you get? They don't have a number yet?
44.93018617.
0930. Okay, so that'll be 44.93. Okay, the units, let me double check my units. So I have grams of C2H6 that cancel out because they're on the top and the bottom. I have moles of C2H6 because they're on the top and the bottom. And I have moles of H2O on the top and the bottom. So that means that my answer is going to be grams of H2O. If you type this into your calculator and didn't get it right, let's double check, go back, make sure maybe you didn't accidentally add a divide instead of a multiply. But I'm going to show you the second way you can do this. This is the way that I do it. And I'm not saying I'm right. I'm just saying I'm slow and I'm stubborn. This way would be pretty fast. The way that I type this into my calculator is I kind of break it up like this. My brain just does this, and that is a-okay. So I would type this into my calculator like this: 25 times 1 over 30.08 times 6 divided by 2 times 18.02. Now, if it's something divided by 1, I don't even include it in my calculation because I don't need to. But if it 1's on top, I have to include it when I do this one. So you can see that this one could probably take a lot more time, but since I'm more comfortable with how to do the math, it works for me. And that would also give me this answer. Okay, both ways work. You got to pick what works best for you and how your brain computes it. We're all different. We're all unique. As long as we're getting the same answer in the end, then good. Are there any questions on that? Okay. Let us practice. So we're gonna kind of go back to dimensional analysis. And we're gonna start working in how do we answer questions that are, of course, short, like actual sentence questions. First, go back to dimensional analysis. We discussed what is a given and what is a want to help us answer. And we might need to come up with some of our own equivalents in this too. How many atoms of hydrogen are in the sample of butane that contains 3.56 times 10 to the 23rd atoms of carbon? That's a lot, right? No, I don't really know how to straightforward answer it. I do know that I want to figure out how many atoms of hydrogen. I do know I'm given this many atoms of carbon, but I need to figure out that equivalence to go between both of them. But they give us butane. What is the chemical formula of butane?
CH10.
So butane would definitely be C4. If you remember, it's H2N plus 2. So 2 times 4 plus 2, H10. Okay. So my equivalence would be for every 4 atoms of carbon, I have 10 atoms of hydrogen. So I need those equivalents. If you feel like you can skip this step and do it all in your head, great. I do it just because I want to make sure I understand what is what. And then once I have my equivalents ready, I'm going to start with what I'm given and do everything to get what I want. So I have 3.56 times 10 to the 23rd atoms of carbon. I want to put 4 atoms of carbon on the top or on the bottom.
Wow.
I want it on the bottom because I want my answer to just be atoms of hydrogen. And if it's on the top, they won't cancel out. I want them to cancel out. So I want 4 atoms of carbon on the bottom. That way I can do like this and do like this, or not the 4, but the units themselves. I want them to cancel out. And then I'm going to put 10 atoms of hydrogen on top. So now my atoms of carbon cancel, and then my answer should be in atoms of hydrogen. Now, you can type this in your calculator by taking this number times 10, enter, divide by 4, or just doing this number times 10 over 4. Just make sure you put the 10 over 4 in parentheses. So I got, first, how many significant figures are in this number? 3. Remember, the 10 is not significant. So my answer, 8.9. I messed up in my calculations. I'm missing a decimal place. 8.56223. 4. Oh, I have to include the 0 then. That's my fault. Times 10 to the 23rd. And always include your units. Did you get that when you typed it into your calculator? Please double check, because I will make mistakes and I love being told I'm wrong when I make those mistakes.
So it'd be 3.56 times 10 to the 23 divided by 4.
So multiplied by 10, enter, and then divide by 4. That's one way you can do it. Or you can do 3.56 times 10 to the 23rd multiplied in parentheses 10 over 4. So it's 2 different methods, whatever works best for you. And then I know you have a unique method. Was yours similar to what I said, or how do you type yours in?
I just typed in 3.56 e to the 23rd times 10,
Okay.
and then divide that by 4.
Okay, perfect. So like the first time I said, yeah.
With the smaller numbers, it was easier to do to my.
Yeah,
Oh,
it's not going to be so easy, but if we have the basics, the harder numbers are going to be just as easy. All right. We're gonna start, I guess, maybe next week, we're gonna start like actually doing a lot more word problems. And I want to just go over and over and over with y'all about how to answer word problems. At any point you are confused by how did I know what I tried to get? How did I know how to start? Never hesitate to ask, because I want to make sure we're on the same page. Because as the problems get a little bit more difficult, I just don't want you to be stuck. So please let me know. I'm gonna let y'all, actually, no. I'll set it up and then I'll have y'all do it. First, let's go through this. How many molecules, and highlight that importance, of dinitrogen pentoxide? What is dinitrogen pentoxide? So dinitrogen, so N2, and then pent oxide, O5. Okay. How many molecules of dinitrogen pentoxide are in a sample that contains 4.910 times 10 to the 24 atoms of oxygen? So in this case, if you don't have the equivalents down just yet, this is how I would answer it. I want to figure out molecules. So if I have one, and I do capital MC to represent molecule. If I have one molecule of N2O5, I will have 2 atoms of nitrogen. Not that this problem needs that, but I'd like to just really ensure that to myself. Okay, I know. And I'll have 5 atoms of oxygen. So I'm going to want to go between molecules and atoms of oxygen. Don't really need this, but just testing myself. Okay. I'll let y'all set it up and answer it, and we'll go through it. Is anyone stuck? Awesome. Let me know if you are. Does anyone need more time? So always start with what we're given. So I'm going to start with the number 4.910 times 10 to the 24th atoms of oxygen. And then where am I going to put the equivalent of one molecule? Top or bottom or top?
One molecule would be.
Yes, sorry, I'm kind of flipping things up. So one molecule of N2O5, and then I will put this equivalent on the bottom. That way, my atoms of oxygen cancel and my overall answer will be molecules. Now, how many sig figs are in this number? 4. So I need to make sure my overall answer has 4 sig figs. So I got 820 times 10 to the 23rd. And always include your units. Molecules of N2O5. Did anyone not get this answer?
Yeah. 9.820 times 10 to the 20.
Oh, okay, maybe. Let me double check my numbers. So 4.910 e to the 24th times 1/5. I got 10 to the 23rd. So,
What I did was 4.90 E 24 times 10 divided by 5.
oh, that's where you went. Okay. This is a 1.
Oh, okay.
Yeah, easy fix.
So times 1 divided by 5?
Times 1. Yeah. So in the previous problem, that's why we had 10, is because there were 10 equivalents of hydrogen. And this problem, because I'm asking for the amount of molecules itself, that's why if you go up here to these equivalents, I have 1 molecule is equal to 2, which is equal to 5. Yeah. Great. Are there any questions on that? Now I'm gonna switch to the skill builder worksheet. We're gonna work on that probably for the next 15 minutes, and we'll go over the answers towards the end. But I want to point out, if you flip it to the back, you have the answers. So maybe we'll just go until the very end and just cover, I'll go over anything that was confusing. But you have the answers on the back of the page. So we're gonna switch to that. And if anyone has any questions, please let me know or put them in the chat.